Hi, everyone. Welcome to our second day of Black in Cardio Week. So today we are starting with an interview with our very own Dr. Stephanie Lindsey. She'll be talking about congenital heart disease. So I'll be the moderator along with, I'm Catherine Chandler. I'm a postdoc at Stanford, and I study cardiovascular disease and especially coronary artery disease and their genetic risk factor. And I'll be doing the moderation of this section along with my co-organizer, Stanley Bufong. So I will let you, Stanley, to talk about yourself, and then I will take it back to introduce Dr. Lindsey.
Okay, so yes, my name is Stanley Bufong. I am a PhD student right now at the University of Bristol. My research focuses on diabetic cardiomyopathy, and we're focusing on the microvasculature of the heart.
Thank you. So, okay, Dr. Lindsey is an incoming assistant professor at the UC San Diego, where she'll be starting her lab in 2021. She's currently holding a postdoctoral research position at the cardiovascular biomechanic computation lab at Stanford University. Her work combines experimentation and computational stimulation to understand cardiac malformation. Dr. Lindsey is an alumna of Washington University in St. Louis, where she did her bachelor, and Cornell University, where she did her master in science and PhD. She has been awarded individual research fellowship from the National Institute of Health, the National Science Foundation, Alfred P. Sloan Foundation, and the Whitaker International Foundation. She was also awarded recently a Career Development Award from American Heart Association and the Brook Wellcome Fund. And last but not least, Dr. Lindsey has held an international research position at INRIA Paris in the University of Montpellier and INSERM. So she has a quite wonderful and impressive background. And I just want to stress it out again. She's an incoming assistant professor at the UC San Diego. She'll be studying her lab. She'll be looking for a PhD student, and you'll have the opportunity to have her talk about that more. So welcome to Black in Cardio Week, Dr. Stephanie Lindsey. We are really, really honored to have you today.
Thank you. Really happy to be here too.
So I will start with our very first question. So you began research as an undergrad. What was that like, and does it still hold any significance for you?
Yeah, that's a great question. So basically, I entered undergrad at Washington St. Louis, and I was part of the federal work study program. And I immediately signed up to do research in a lab. And first thing that I did was they assigned me to an anesthesiology department, and I was just washing dishes and making media and doing my homework in lab. And I really enjoyed being in a lab, but I wanted to do research that was interesting to me. And so then I started asking around to my professors, and I joined the biomechanics lab of one of my professors at the same time that I was taking his class. And that was a really formative, really great opportunity for me. And really it helped build me as a researcher, shape my vision of research. And so when I entered undergrad, I was pre-med, and being in this lab really helped me see how much I love doing research, how much I love development. So I entered Dr. Larry Tabor's lab, and it was a mechanics of morphogenesis lab. And so morphogenesis is really how structures morph and change. And so in development, how a structure is changing to become its full functional self. And that's a large part of what I do still. And also he did experiments, and then he would use these computational growth models to explain what was going on inside the experiments and to further ask questions. And that's very much a part of what I still do and what I'll do with my lab going forward. So.
Wow, that's amazing. That's really interesting. It's great to hear what you did on undergrad. So our second question is, all your degree are in biomedical engineering. How did you choose engineering, and what is it like to study cardiology from an engineering point of view?
So when I entered undergrad, I actually entered into the School of Arts and Sciences. So, in the US, usually you have School of Arts and Sciences and College of Engineering. And at WashU, they had the undergrads come early, and you did orientation programs that were related to what you suspected your major would be. And I had written biology. And so when I went to the biology orientation, I would sit in this huge lecture hall, and they would talk about how they were going to take the math out of everything and how little math we would have to do. And so both my parents are engineers, and I have an older brother, and we grew up, doing math problems to compete against each other for fun. And so it sounded really not appealing to me. And then at the same time, I also saw a lecture on biomedical engineering. And to me, it was as if someone had created a major specifically for me. So it was all about creating new technologies for medicine. And so I actually switched into engineering right before the start of classes, and then stayed in biomedical engineering for my entire career. And so how that affects how I study cardiology and how I go about my work. So today is Whole Heart Day for Black in Cardio. And I do very much look at the whole organ as a whole on a large scale. So not so much molecular, maybe little parts and little cellular attributes. But I look at how blood flow affects cardiac development and how it'll change the four-chambered structure. And so there's a number of congenital heart defects that we don't understand how they form. And that's part of what I do. That's what I did for my PhD, and what I'll be continuing to do in my lab. And part of the reason that we don't understand is because it's so complex, and then also because people have been coming at it from the same perspective, and largely a genetics perspective and molecular biology perspective. And so it's really refreshing and rewarding to come with this new set of tools and be able to be really creative and think about things in a different way. So it's something I really enjoy.
That's great. So thank you for bringing the fact that today we're talking about the whole heart, which actually brings us to one of our questions was you start talking about it and timing in. So your background is engineering, so you could have done a lot of different things. You could have done, even in the world of cardiovascular science, you could have done modeling of vascular world, blood vessel, and everything else, but you chose to work on congenital heart disease. I think it's not enough known. And my very first question is, why did you choose to work on congenital heart disease, and what type of congenital heart disease do you work on? Tell us more about this.
Okay, so yeah, as I said, I wanted to be a physician, from the time that I was little, actually. And I also have always loved children. So, like I was 5 and I thought I could babysit other children, right? I always wanted to take care of other children around me. And then when I was in middle school, so basically I always thought I would be going to pediatrics. And then when I was in middle school, I experienced the loss of a loved one who died from a congenital heart defect. And then from that moment on, I've always been fascinated by the heart. And so from that moment on, that became my main passion was the heart and studying the heart, and definitely pediatrics. And so I wanted to be a pediatric surgeon, pediatric cardiovascular surgeon, and I would just study the heart all the time. And so it's largely, very personal passion of mine, and something that I chose from the beginning that I wanted to study.
That's really amazing. I think having a personal experience of a loved one that you lost from such a for any type of disease, and from congenital heart disease in particular, I think it can really shape your passion, and I do understand how, it's amazing. So our next question would be, so you do research, and you are smart, and you have such a strong passion, and we really see that in what you say. But what I will say is you can be a valuable resource for industry as well, and you can do as well in the industry, but you chose to stay in academia, you chose to start your lab. And the question is, why did you choose to stay? And you could gain much more money in industry, of course, but like the question is, why did you choose to stay in academia with such an amazing background rather than going to industry?
Yeah, so I think for most of us researchers, like I never really considered money actually. And then I also never, industry was never really one of the options that I thought of for myself. So when I decided I was going to get a PhD, I thought the path that I would go to would be working for a research hospital, because what was really important to me was affecting change. And I thought that the best place to do that was a research hospital. Also, I was in St. Louis, Missouri, and St. Jude Medical is huge, and they were always coming to WashU's campus. And so I thought, ooh, St. Jude Children's Research Hospital, something like this will be perfect for me. And then I think largely that started to, so even during most of my PhD, I said research hospital. I never considered industry, but I also never really considered academia either. When I was an undergrad, occasionally we'd have a professor who would teach one class and they worked for industry, which I thought was cool. So I'm like, okay, I can teach one class, work for my research hospital and all of these things. And I met my current postdoc advisor, so Dr. Allison Marsden, during my PhD. It was a little more than halfway through with my PhD, and she was able to do everything that I ever wanted to do from an academic position. So she has a double appointment, well, she has a triple appointment, like bioengineering, pediatrics, but most importantly, she was working with surgeons. She came up with new medical devices that were actually being used and implanted. And I just saw that she was able to do all of this from an academic position. And then the idea of mentoring people, people like me, or people who really just like helping them find their passion and being able to mentor them also from the academic position seemed like a really great fit.
That's wonderful. So we want to pause a little bit and just remind everyone. So thank you all for attending. So we see that we have a number of attendees here, but please ask questions to Dr. Lindsey. We want to turn this into a conversation rather than us asking her a question. So we really want to make sure that you are all timing in, asking her anything you want. So she brought up a lot of very, very important and interesting points yesterday during the career session. And I think this is also a great opportunity to have her extend more on that. So, and also we are live broadcasting. So anyone listening to us on Twitter or Facebook or YouTube, make sure to type your question in the comment. So we were gonna get that, and we will make sure to ask the question to Dr. Lindsey. So we will pause just a little bit to see if anyone in the audience have any question. And please don't be afraid of asking your question. Oh, great. We have a question. We have a question from Julie. A lot of apologies if I'm not able to pronounce your name properly. I will try. Julie Segenthaler from the University of Colorado. She's a pet dev bio. She'd like to hear about the model system that Dr. Lindsey is studying.
Yeah, okay, that's a great question. So I use, for everything that's dev bio, I use the chick embryo for my experiments. And so the chick embryo is a really popular model for mechanical models of development. And that's because basically you have access to its entire vasculature on top of the egg yolk. It just sits on top of the yolk sac. And so basically for my experiments, I'll do mechanical perturbations to change flow patterns, and then that'll change flow patterns during development, and that'll change the pattern of the heart when it's forward chambered and fully structured. And that's my main model that I use. And currently for my postdoc, it's more on the peds than on the dev bio side. And so I'm working with a sheep model that's being implanted with tissue engineered vascular grafts. And that is to inform a current clinical trial that's going on. So we have like a large animal model to inform the clinical trial. And then for my more basic science, I use a tick embryo, but it's, even though it is basic science, it also is easy to, through your computational models, also to help it to go to be translational as well, which is cool.
Great. So I also want to stress out that we can allow attendees to ask their question directly. So if that is something that you would like us to give you the opportunity to talk, let us know. So we have a second question from Elizabeth Bentley. So I'm a second year PhD student at the University of Pittsburgh, wanted to know how challenging was it to apply to faculty position? I've heard that it is relatively difficult given the limited number of spots. In addition, do you think there was any one thing that stepped you apart from other applications? Thank you, Elizabeth.
Yeah, thank you, Elizabeth, for your question. So it is a very long process, especially if you compare to people applying to industry, for example. It's a very long process applying for faculty positions. And anyone who is applying, I have a lot of advice and materials and tools that I can share with you. So please do contact me if you'd like more specific. But I would say, if you have a vision for what you'd like for the future for your lab, then you're already writing the grants and seeing it into the future, how you're going to advance your research. And so actually writing the faculty applications was quite easy because I just took directly from my grants and the vision that I've been cultivating and I have for myself. And I'd also like to say that at the end of my PhD, so that's when I really decided, okay, I think I want to go into academia, even though that was not, I was not headed on that track from the beginning. And so the last year I was one of the student panelists for the faculty search. And there was an open faculty search at Cornell, and it was for women, but like any subject area. And the 5 finalists who came for their in-person interviews were all people who had done really long postdocs. Actually, I think they'd all done 5-year postdocs. And they'd done their postdoc in something that was different than what they did their PhD in. For example, someone was a physicist and they did their postdoc in developmental biology and these type of things. And so what they had when they were for their applications and for what they were talking about for their lab was this unique vision that they were capable of doing. And it's because they were synergizing these things that they were uniquely trained for. And I think that's a large part of how I felt going on the market as well. The faculty market is that I have what I really like. I have my own unique tools and I know what they are. And so I just highlight that for my faculty applications. And so it's really kind of finding your niche and then explaining that to other people, just highlighting what makes you you kind of thing.
Wonderful. So I just want to ask Elizabeth if she wants to let us know if she got her answer or not. I can let her talk. Otherwise, we will move to next questions.
Yeah, that answered it. Thank you so much.
Great. Thank you. So I'll turn into my moderator, Stanley. I know we are live broadcasting. So do we have any question from Twitter or else you can also, I'll let you just ask other questions.
Okay. Thank you, Catherine. And thank you again, Stephanie, for joining us. I'm going to ask some questions to get a bit more into your experience as a PhD student and as a researcher when you were doing your PhD. So I know that you did your PhD in France. Am I correct?
Oh, I did my PhD at Cornell, and I did spend 6 months during my PhD. I spent 6 months of that time in France, and one of my committee members was from INRIA in Paris.
Nice. And how did you find that? How was that experience being from America, going over to France? How did you find that experience settling in? Because 6 months is still quite a lot of time to spend away.
Yeah, it is. So I really enjoyed it. So yeah, I did my PhD in Ithaca, New York, and I loved what I was studying. A large part of what I'm doing in my will do in my new lab is coming from my PhD and then adding these skills that I gained in my postdoc. But Ithaca was very hard for me because it's really cold and it's also really isolated. So I wanted to go away. And so basically I was an NSF GRFP fellow, and I highly encourage everyone to apply for fellowships and have your own funding, because that gives you so much flexibility with what you can do. And also so many other opportunities open up for you once you do gain these particular fellowships or grants, and you get a large community to support you. And so NSF came up with NSF GROW, which stands for Graduate Research Opportunities Worldwide. And so I was an inaugural GROW fellow. So only NSF GRFP fellows could apply for this. And I think they released the announcement for it maybe in late November or December, and it was due in mid-January or the end of January. So there really wasn't a lot of time, but I knew that I wasn't able to study abroad for a whole semester in undergrad because I had so many course requirements, and I always wanted to have some kind of international experience be part of my research. And so I knew I wanted to go abroad, and I thought this would be perfect. To use NSF GROW, they're giving me funds. And so basically I went onto Google Scholar and I typed all the keywords that I wanted to learn or describe my research. And then I would type France. And then I looked and I saw all of the researchers who would come up, and I emailed them all. And I emailed them all saying, I have my own funding. I want to come visit you. I want to learn these things. And then I saw who replied back. And so that's how I established this collaboration with a really great collaborator and friend now from INRIA Paris. And for going over there, NSF helped a lot with the visa and everything, because it's always so much paperwork. And then I guess I went to learn new techniques. And so it was not so different than being in the US. It's just, in a new environment and with all these new people who were willing to share what they have and what they have and what they do with you. And so that was really great. And it helped change the direction of my research when I went back to the US, actually. And then I added my collaborator as a member of my thesis committee. And we would continue to meet every 2 weeks until I graduated, actually.
Nice, that's very good. So we do have a question here. It's from an anonymous attendee. It would take us actually right back to your research, but I think this is a very good question. It's a two-part question, so I'll ask the first part first. It says, hi, I am a Black woman with CHD diagnosed from birth. What do you think can be done to do more advocacy / awareness of CHD in Black communities?
That's a really good question, and it's a hard question too. So it's so funny because childhood cancer actually affects less people than congenital heart defects do, but actually more people know about childhood cancer. And so I think part of it is that they're often complex and hard to understand, congenital heart defects. and so many people suffer from cancer. And so then you're like, oh, childhood cancer, okay, like we understand what this is. So cancer actually is used in a very broad way, the term cancer, because there's so many different kinds of cancer. And so I think part of it, so that's definitely science communication, and it's about being able to explain it to people in a way that they understand and sharing your story with as many people as you can. So I think that's part of it. Yeah.
Okay. And the second part of this question was, what can we do to get more Black people working within the field of congenital heart disease?
I think a lot of that is mentorship and support. And so another part of that is being visible and open with people and letting them see you and hear your story. And as someone who's in science, it's helping pull people up and helping them learn what you do. I had no idea what biomedical engineering was. And so they can discover it and discover that maybe they're passionate about it. And so definitely activities like fairs. My PhD lab, we would go to the state fair every year and we would put on a booth and we would explain to people all about development and all of these different things. So it's really trying to introduce these concepts to kids and to find people who can help encourage them and continually encourage them along the way. So yeah, I think it's like a lack of knowledge about it in the first place, and then finding people who actually encourage you instead of close doors for you. So it's part of it.
Yeah.
Right. So maybe Stanley, did you have another question? I just want to come back to Julie, who she has a follow-up question. So I wanted to give her the opportunity to ask her follow-up question, and then we move to the next question by, I think, and I'll let you back, Stanley, to ask Jason's question or if he wants to talk.
Hi, can you guys hear me?
Yeah.
Yes.
Hi, I'm Julie Siegenthaler. You did a great pronunciation of my name, by the way. Thank you so much for letting me talk. So what I was thinking about was, you're talking about your work with blood flow and heart morphogenesis, which of course is really interesting to talk in the context of congenital heart defects. Do you think that there's any application or information that you can get from that connects to heart failure that happens with aging? Is that something that you've thought about or had to write in your grants? So yeah, if you could just talk a little bit about that, that would be really interesting. So
yeah, so I guess so my PhD advisor, he taught a class that was called natural engineering. And basically in my PhD lab, it was focused on heart valves and both heart valve development and disease. And kind of his like paradigm was that if we want to, first of all, it's like if we want to understand, if we want to change something, we have to understand why it's forming. So that's, all of us as like researchers. But then it was, how can understanding development help us reverse like the malformations that are forming, kind of thing. And so that's definitely, it's kind of the question that you're asking. And so basically, I think for that, going to a more maybe molecular and cellular level, like what are these important components that were involved in helping get this area of the heart to be the way it is? And so now, like if those areas aren't functioning properly, can we somehow re-induce these cells to behave in the same way they would in development to repair? And so can we do that mechanically or chemically, biochemically treat it? That's how I would go about studying it. And so I did study a little bit like heart failure because pediatric patients who, survive their congenital heart defects often end up with a number of complications as adults, and that's because a number of the treatments are palliative, meaning that they can't correct for the defect, but they can make the defect sustainable. So, they can grow into adults versus if there was no intervention, they wouldn't have been able to. And so along that end, I was studying devices, so left ventricle assist devices, artificial hearts, those kind of things. But I really like the idea of trying to rebuild, and I think development can help you do that a lot. Just so studying development and seeing which principles from that you can apply to adults as well.
Thank you, Stephanie. I will go back to Stanley and let you ask the following question from Jason.
Okay, Jason asked, how did you find the difference in research cultures between the US and Europe? So is there a difference, first of all, and what is that difference and how did you find it?
Yeah, there is a big difference. And I think part of it is in the structure. And so in the US, we don't have, especially in academic labs and research centers, we don't have a lot of permanent scientists. It's, in academia, you normally have your PI and there's like the postdocs and, maybe like one kind of research scientist who works in the lab, but there's the postdocs and PhD students. But in Europe, it's a lot more nested. And so, for instance, an assistant professor won't have their own lab to begin with. They'll be contributing to another group leader's lab, that kind of thing. And there's kind of a, so I guess for me, that's always something to consider when thinking about doing research in Europe. It's how many people will you work under and how much power do you actually have yourself to be able to do something? But I think it's the same spirit of research. We're asking a question and we're trying to get to an answer. Funding, I also found to be quite different. So in France in particular, that's what I have the most experience with. A lot of funding from industry directly for a PhD student, and not as many funding opportunities, and PIs aren't always writing all these huge grants like they do in the US. And so that's very different. And so I think in the US, maybe we tend to consider cost a bit less. And so I think that's also part of it as well. But yeah.
Thank you, Stephanie. I just want to make sure that Jason has his answer. Do you have any other question, or do you think you got your answer?
Hi, can you hear me?
Yeah.
Yeah, I just wanted to, you basically answered it, because I think a lot of people, you get people going up to the US from Europe and not necessarily much from the other way. So that's why I wanted to ask about your experiences coming over to this side as opposed to the other side. But I think I got my answer. Thank you.
Thank you.
Great. So thank you so much. I don't know, Stanley, do you think we have questions from the live?
Well, there is questions more about yourself, I guess, and your experiences. As a Black woman in science, how did you find the challenges? Were there any challenges that you faced, and how did you overcome them?
Yeah, so there are a lot of different kind of challenges that I faced. And I don't know how many of you have seen Picture Scientist, but I recently watched that and I felt as though it voiced so many of the things that you experience. You can call them microaggressions or forms of sexual harassment, and that you you didn't exactly know what category to put them in or how to describe them. And so they had these huge iceberg metaphors. And I found that a lot of the things that were in the iceberg, so basically the iceberg was all these things that happen, and most people consider sexual assault to be something that's only physical. But then below the iceberg are all these other microaggressions, you can call them, such as maybe being left off an email with a collaborator. So, you know, for me, it's like, they're setting up a new collaboration, someone's coming in just for your project, and you respond to the collaborator, they don't respond to you, they email directly the PI maybe, and like the PI, like to talk about you and to like answer a question you asked or something, but they don't want to interact with you, like those kind of things. Or from like even being in class, maybe like one time I was in a group project, and having someone not take anything that you say into consideration until the exact same thing is said by maybe a white male or someone else, and then they like actually take it into consideration, those kind of things. And even I've been berated like in front of a room of people, you know, a room of typically white males, giving a presentation, or been told that what I was presenting was stupid, like those kind of things. And a large, I guess, how I deal with it is kind of separating what is about you and what isn't about you, and what's their problem versus your problem. And talking to, you know, my family and my mentors and support network. And one thing that my aunt told me once was, if you basically did what people expected of you, or you followed their expectations, you would only ever be, you would be either cleaning people's houses or watching their children. And so you can't get who you are, what you should be from other people. Like that's really important. And so my family's really great. My parents are both engineers, and when my mom, you know, graduated, she was the only female and the only Black person. And so that's always been something of, it's okay to be an only, do what you do well, and recognize when it's really not your problem and how you can get around that kind of thing.
Yeah, that's amazing. Very, very powerful words, and I think some wise words from your auntie as well. That's good. I'll hand over to Catherine again.
Yeah, so thank you for bringing that. And that brings me actually to my own question. So I just want to follow up on, as a Black women in research and in the world in general. I know we are exposed to a lot of imposter syndrome. We are exposed to a lot of microaggression. And often I would say we talk about unconscious bias a lot. But I do believe that sometimes people don't even realize that that's what they're doing to us. So, but unfortunately, that will shape how we take things and how we will be acting or responding back. So my question to you is, have you ever felt like when you are interacting with someone, have you felt that the question or the interaction is because of you as a person, because of you as a Black woman, or because of you as a Black? So how many times have that thing run in your mind before you answer to the question that you have been asked, or before you continue the interaction?
So it's kind of impossible to really get at people's motives, but you can understand when there's a problem. I mean, so for me, it's like at first maybe you're like, okay, they don't understand like, you know, who I am or how hard I work or all of these different things. And you just keep trying. And then you know, hit the same kind of roadblocks and everything. And you realize that they're just always going to be hostile towards you or these kind of things. And so if you have to work with them, it's really just kind of making sure that you shape your narrative with them in your mind. You're like, okay, I need these things from this person. We'll get exactly these things. I need these other things, like for myself to advance or for my development and all these other things. And I'm going to get those elsewhere. And also, so I have really great mentors from just throughout my career. And whenever I had really hard times, I would make sure that I emailed them, I called them, I discussed things with them. And a lot of times just talking to someone else and feeling heard or seen really helps. And they can help you make a plan for what you're going to do and how you'll get away from a certain situation. Yeah.
Great. Thank you for stressing out again the importance of mentorship and having people that are backing you and supporting you at all times. So we have one question, I think, and I would love to have us, if to have the audience also keep on asking questions. But this is a great question from Dan Terrier. I will ask him to ask his question, but it's about your lab. And we want to make sure you will tell us more about your incoming lab and what are your plans. So let me just ask, let Dan ask his question. Oh.
Hi, can you hear me?
Yeah.
Yes.
Yeah, so thanks for doing this. This is pretty informative. And I guess my question is just, what are you most excited about for your own lab? And it's actually cool that you're going to UCSD, because my PhD mentor moved to UCSD a couple years ago, but he's at the other end of the spectrum. He's in the gerontology. So maybe you guys will cross paths, but I'm not sure.
Okay, so the main question is, what am I most excited about? And what I'm most excited about, so for me, so I love development and congenital heart defects, and there's a couple of congenital heart defects, the ones that really touch me personally are the ones that I really want to study. So I study congenital heart defects of the outflow tract, and that means when flow is leaving your heart, so the aorta and the pulmonary artery, those are part of your outflow tract. And so I study defects that occur from malformations of outflow tract. And during development, the pulmonary artery and the aorta, they'll start off as one vessel before they divide into two. And one of the most severe congenital heart defects is hypoplastic left heart syndrome. And so it's when your left ventricle is severely underdeveloped, almost to the point of being non-existent. And this requires a series of 3 surgeries. And so the first one has to be done within 24 hours of birth. And really it's because, your ventricle, your left ventricle is the pumping chamber of your heart to move flow, to your body, supply the oxygenated blood to your body. And so the rewiring of the heart is what they're doing in these 3 surgeries, and it's ensuring the separation of oxygenated and deoxygenated blood, and that your body can get the oxygenated blood that it needs. And so the 3 surgeries, they give a lot of people hope. And, before it was just lethal, before these were even possible, but they are palliative surgeries. So basically, a lot of the patients seeing cardiologists, they actually are patients with complications from these surgeries. So, they live to adults and they still have all these complications. And for me, what I really want to do is I want to be able to design in utero surgeries that would actually give them back the function of their ventricle. So no one can grow you a ventricle, after you're born or anything. But if we really understand exactly when, the timing and everything about why this defect is forming, maybe we can reverse it, or maybe we can prevent it from happening in the first place. And so so all of these things, they'll take, my career, and all of these things are maybe longer to do. But what I'm really excited about is being able to pursue that, and maybe to come up with all these new kinds of in utero surgeries that could change, how we treat certain kinds of congenital heart defect. And so that's kind of what keeps me going, both for the developmental biology and for more in silico medicine, is really trying to create tools that will really change how we do surgeries.
Wow, that's quite powerful. That is very passionate. You have a lot of passion, and that is quite impressive. So just an idea of designing an in uterus surgery, it's great. I think it would be really revolutionary for the field. Still want the attendee to ask question. Please make sure to ask your question. Stephanie is here with us again for 12 more minutes, so it's never too late to ask questions. Anything you want. Of course, with the respect to Dr. Lindsey. So how we talk about what you do outside of science, because being such a smart and great researcher, you probably have some little tips for life and work, life and science balance. So tell us more about what you do outside of science.
Not always great with the work-life balance, depends on the grand cycle and everything. But I do always like to have a lot of activities to keep me busy. And so I swim. I did that growing up in high school, and it's something that I continue to do. And I actually just did my first semi triathlon a couple of weeks ago.
Wow.
So open water swimming. Actually, the swimming part's really small for the semi triathlon, but it was still really fun. And then I learning to play piano. So I took lessons when I was younger, but basically, usually I sing in a choir as well. So doing something that's active and also something where I feel helps me express myself. I like doing those things, and definitely cooking and eating a lot too.
That's great. So we need to find something that keeps us up after thinking a lot about science. So that's very important to free our mind and get new energy. So I want to come back again to your lab and ask a question about what are you looking for in terms of training, in terms of people that you want to join your lab, and where can we find those information?
Okay, so at UCSD for the PhD program, you're actually directly hired into a lab. And so if you are considering going to UCSD, you should consider going to UCSD for your PhD, and you would just apply to UCSD and say that you're interested in my lab and email me beforehand, and we can talk about things. And so basically, so a lot of what I do is fluid mechanics, some soft tissue biomechanics as well, and then computational modeling. And so if you have interest in these fields, and then definitely developmental biology is a huge underlying part. And so looking for people from different types of backgrounds, and possibly a postdoc as well. And so so basically people who are interested in mechanics and development. That's largely what I do. And so I am looking to study a key cellular population and use some genetic techniques in the chick embryo as well. And then modeling both on the developmental side and also working with physicians the same way that I do now during my postdoc to do in silico modeling of surgeries and patient geometries as well. And so, yeah, those are the things that I'm looking, that I'm going to be doing in my lab. And definitely when you're starting out in your PhDs, those are not skills that you have to have. It's just you have to be interested in. And so those are classes that you take a lot in the beginning, fluid mechanics, numerical modeling. So it's kind of funny because when I was looking for PhD programs, I did not apply to computational labs. And now I'm purely in a computational lab, and I find it so cool. But whenever I was reading the descriptions, I thought it was really boring because I was doing experiments in undergrad. And so definitely I combine the two, and I iterate back and forth between experiments and simulations on the developmental side. And so if you're interested in one or the other, I think we have a place in my lab for that.
That is amazing. So I also want to touch base on, you are currently wrapping up your postdoc at Stanford in the Cardiovascular Institute and Cardiovascular Computational Lab. So I wanted to tell us a little bit about that, like your experience as a postdoc, how and what are you doing while you're finishing up and starting your lab, but also we have so much to talk about. Also, you wrote a tremendous amount of grants, and you have a lot of awards. So just a couple of tips about writing grant, not giving up, searching for funds, and your life at Stanford.
Okay, so I guess I'll start with the grant writing aspect. And so grant writing is so important, actually, at all different stages of your academic career. And so the first like individual research fellowship that I was awarded was actually as an undergraduate. And so, you know, I started doing research for my professor, and then one of the deans in the College of Arts and Sciences applied to for an institutional grant. So it was an NIH MARC U-STAR grant, which when I was awarded stood for undergraduate student transition to advanced research. The acronym stays the same, but the words actually change sometimes. And basically, I was awarded this my senior year, and it allowed me to spend more time in the lab. So it gave me a stipend, and it actually filled the gap between the scholarship that I was awarded and what my parents were responsible for. And I thought that was so cool. And then when I went to Cornell, they really encouraged us to apply for NSF GRFP. And they gave us a seminar on how to write it, and you would work with your advisor who would read those drafts and help you write it. And so I very much learned how to write grants from my mentors. And so my first experience was as an undergrad, and then just first year of grad school, my mentor really helped me to hone that. And so I applied for, and whenever you have your own funding, you have so much freedom. And so I got to study exactly what I wanted to study because I was always funded. And so that's why I'd always just keep applying for funding. If you like want to do something and be able to do it, you're like, I'm free, like, you know. And then when I arrived at Stanford, my mentor really encouraged me to apply for all of the big career grants. So K99, Burroughs Wellcome Fund, AH8, all the big career grants. And it was a really good experience. And for that, I also took a class that helped me to learn how to write your specific aims, a timeline for how you should prepare them and everything. And so I guess happy to share any resources and information that I have with people, but I really encourage the grant writing. And for me, it was always it's a very learned task. So don't forget that. And then getting feedback from, you know, tons of people. And so being a postdoc at Stanford, Catherine is actually one of the first people that I met when I arrived. I think I met you like my second day at Stanford. There was a brunch in the pediatric cardiology department, or just for pediatrics, and we're both in pediatric cardiology. So that was really nice. So my lab has we have a bunch of postdocs. Our lab is, you know, all computers, right? So everyone works with a physician or maybe biologist to get our data from, and we just all, you know, are always on our computers. But it has a really great atmosphere of, if I can help you with something, let me know, and we pass things on to each other all the time. And so being at Stanford, I love being in Dr. Allison Marston's lab because of the environment. And it's the first time where I was in a lab where basically I wasn't a side project. So I wasn't largely off in the corner, like working on my thing and not being able to troubleshoot or talk to anyone but my PI. And where I felt as though I could learn something from everyone. You know, PhD students, postdocs, we all have something and have really similar interests. And so that was really nice. And so finishing up is really, I'm on a really large collaborative project. And so I think of this year as kind of a bonus time for me to be able to finish up publications, which you also need to get more grants, and to keep working with these really great collaborators that we have. And also some of the collaborators, you know, some of them are trainees also who are starting their own positions as well. And so making plans with them for grant writing for the future and things like that too. Yeah, did that answer? Your question was long. Was there anything else?
Oh, no, that was perfect. You
Okay.
touched base on everything. That was really perfect. So we have 2 more minutes to go. If any question again in the attendee, thank you so much for joining. Thank you so much, Dr. Lindsey. I call you Stephanie because I'm so used to it, but Dr. Lindsey. And thank you for everyone listening to us today. This was a wonderful interview, and we really did learn a lot. And this is a shout out to every PhD postdoc that are looking for transitioning to the next career. You have to try. You have to keep on going. And Dr. Lindsey said yesterday, don't let anyone or anything get into your way, because you are amazing. And what we really want to make sure you all understand is that you are all amazing and you can accomplish everything that you want.
And most importantly, yeah, there are people who want to see you succeed. Like, you may be coming up against people that you feel don't want to see you succeed, but there are people who really want to see you succeed and support you. And it's just a question of networking and finding those people. And I think, you know, here we're all among those people, so you can reach out and contact us. And then also, speaking of fellowships and grants, you know, Burroughs Welcome Fund, which is one of the career development awards that I was recently awarded, they have a postdoctoral enrichment program. I think really encourages minorities and people to apply for, which I would encourage any postdocs or people finishing their PhDs to apply for, because every fellowship and grant that I have been awarded has opened so many doors to me, and it also provides you with more community. And so those things are so helpful. So I would just, you know, keep your eye out for what kind of funding opportunities you can apply for, and definitely go for them.
Thank you so much. Stanley, do you have anything to say?
No, but just thank you very, very much. It has been very powerful. We've learned a lot. And as Catherine has said, it is a message, a word, and advice to all early career researchers, PhD, postdoc. And again, a shout out to remind people that you are looking for people to join your lab as well.
Yes,
So if anybody is looking for something or really wants to, actually, are you looking for people from the UK as well?
yeah, from everywhere.
Yeah. Okay, so that's right, folks. So from everywhere, you should just apply. I'll be applying as well. So yeah, thank you again.
And we will make sure to have her information available on our Black in Cardio website. So so keep an eye out there. And Dr. Lindsey do have her profile, I think, on the Black in Cardio website, right? You can easily get, yeah, you can, if you look there, you can easily get her name and you will see her website, and you can apply, you can reach out to her. And please let us know if you want to reach out to her. We will be happy to help. And we are 2 minutes over our time. Thank you so much again for your time. Thank you for being here with us. Thanks to everyone who joined our Q&A today. Your time is very valuable to us, and your question as well. So we want to make sure that we are offering you everything that we can. We will end this session for today. And one thing though, keep connected. We are having a live chat with the AHA. So keep on following us, and we'll have a couple of questions there, and you can answer those questions. Thank you again, everyone, and see you tomorrow for our next section.
Thank you, Catherine. Thank you, Stanley.
Thank you. Bye-bye.